Okay, uh, welcome all. In the second part of the word count analysis program, we will discuss about the implementation and the execution of the code. Okay, so first thing is let's start the Eclipse software. Okay, so we will be using the Eclipse for compiling and running the MapReduce programming, and we will be using the Java language for coding part. Okay, so okay, right. So our Eclipse is now up and running. We'll what I'll do is I'll be taking things parallelly. That is explanation of the code as well as execution of the code. Both will be I'll be doing it parallelly. So once we have opened the Eclipse, now what is the next step that you need to do is we have to create a Java project. So for that, let's go to the file option. Okay, from here we'll go to the new. From that, we have to select the Java project. Okay, so once you get the Java project, so can give some name here. I'll be giving it as say word count. Okay, then click on the finish. Once you are given the name of the project, you can just click on the finish. So you can see here on the left side, the word count project is created. Now let's go to this word count, right click on that project, and you have to go to the properties. Okay, bottom C here, you have to go to the properties. So click on that properties. Once another properties window opens up here, you have to click on Java build path option here. Right now, here you have to select the libraries. Okay, then you have to click add external jars. Okay, here you have the option add external jars. So click on that add external jars. See, what is this external jars? Okay, this is basically the jar files, the supporting jar files which are required for execution of the MapReduce program. Okay, so we have to include this jar files so that our MapReduce program gets executed. So these are all external jar files that we are including in our project, that is word count project. So we'll be having this jar files which are on the desktop that I have stored. So it depends on wherever you have stored, just you have to go to that file path, and once you find that jar files, so open that jar files, and you have to you have to select all the files here. So I'll be pressing Control A so that I'm able to select all the files here, external jar files. Then once it is done, so let me just click on the OK, right? Then OK, right? So we are done with this part. That is, we are able to now include all the jar files, external Hadoop jar files, whichever is required, okay, for execution of the MapReduce program. Okay, okay. Now after adding all the jar files, external Hadoop jar files that are whichever is required for execution of the MapReduce programming, now we'll just start with the coding part. Okay, so let's create some classes here. So let me just go to the project, that is the word count, and I'll do right click on that, go to new, and here I'll select the class. Okay, so once I clicked on that, another window will open up, and here it is asking for the name. Type the name of the file as okay, anything like say word mapper is one of the class that we are creating. Okay, then just click finish. Yeah, so you have this file, that is the word mapper. Okay, now what we'll do is, okay, so once we have created a class file, that is the word mapper.java. On the same lines, let's create two more files. Go to the project, right click, go to new. From there you can go to the class, and one more file I'm creating, word reducer. Okay, then similarly I'll just first create all the files, required files. Okay, then we'll see the coding part. Now again I'll go to the project, that is the word count. So right click on that, new, and one more class file we are going to create, Java file we are going to create, say word count. Name of that is word count, and click the finish. So in total three separate files we have created. One is word count, the other is the word mapper, and the other one is the word reducer. Right. So now once we have created these three files, let's see the coding, what has to be done in the, what is this word count dot java responsible for doing, what word mapper code we have to write, logic we have to write, and what the logic that we have to write in the word reducer dot java. Okay, so just to keep the video simple and small, so what I'll do is I'll just take the code which is already present here, and I'll just paste it, and I will explain that code. Okay. So this is what is the code. Let me just select all, Control A, Control C, and yeah, paste it in the Eclipse environment. Okay, right. So this is about the word count.java. So this is going to act as a driver program, like a main program, okay, main function, okay, driver program, word count. Then comes the word mapper. So just let me open this word mapper. Okay, it's a very small one. Let's Control A, Control C. Then we'll be pasting it here. Okay, so this is the word count.java, the driver program. This is the mapper program, and finally the reducer function, or the program that we have to now see. Let me open this. Okay, so this is the reducer code. Control A, Control C, and let me just paste it here. Yeah, so these are the three files that we have to create. Okay, that is word count.java, word mapper.java, and word reducer.java. Okay, let me just save all of the three here, word mapper, then the word reducer. Okay, so before we go for the next part, how to execute this particular programs, now let's see uh, a bit in detail about the code. Okay, starting from the word mapper. Okay, I'll just start from the mapper. See, here we have some of this files, packages that are going to be imported. All these are required for the execution of the MapReduce code. Then we have a class called by name word mapper. We have created that here. Okay, that's why I given the same name. And this word mapper extends the MapReduce base, and it implements the mapper. And with this arguments, that is long writable, text, and int writable. Okay, so these are very important points here. I'll just explain it in detail at this point of time. That is, what is this long writable? What is this text? What is this another text, and int writable? See, these are all the data types. They're all built-in data types of the Hadoop. Okay, so the way we have int, float, char, double in C language, similarly we have long writable as one of the data type. Text is the another data type. int writable is the another data type which are available in the Hadoop framework. Okay, so why these four we are using, and what is the significance of this? See, we know that for the mapper we are going to give two inputs. One is the key value pair, input in the form of a key value pair, and the mapper will do some processing of that, and it is going to give the output again in the form of a key value pair. Okay, so first two arguments that you have here, data types, that is long writable and this text, they represent the data type of the input given to the mapper. So if I have to just show you, let me just open this. Okay, here we had discussed it in the previous part also. Now this one, key and value, we have it right here. So now this key, this particular data type, the data type of the key is nothing but long writable, comma, the value, the data type, this one, see, this byte offset we had, right? 0, 18, 31, 41, like this. Its data type is long writable, and this value, that is hello, how are you? This value is nothing but the text. Okay, so this is a pair, long writable and text, which is given as an input. So the data type of key is long writable, the data type of value is text. So that is why we have long writable comma text. Then next here we again have this third one, that is the text comma int writable. Okay, so this is the uh, data type of the key. I'm talking now about the output key value pair of the mapper. Okay, output key value of the mapper. One is the text, another one is the int writable. So here, whatever you see, hello, how, are, you, hi, I, am, or all this, these are all having a data type of text. And you have this count 1, 1, 1, 1. Its data type is int writable. Okay, so that is the reason why here we have long writable comma text, text comma int writable. So first two are the data types of the input key value pair. The second two are the data types of the output key value pair. Okay, right. So once you are inside this, then we have this public void map function. See here, map function is taking long writable key comma text value. So what is the data type of key? Long writable. What is the data type of value? Text. Okay, so it is taking that. Then output collection, text comma int writable, then output comma reporter R. See, this is one of the object that we are creating for output purpose, and you can see here again its data type is text comma int writable. So this is what is the output key value pair, data type of the output key value pair. Then we have one more here, that is the last argument, that is the reporter R. So usually we don't use this reporter R. Basically this is used for debugging purpose. Okay, so let's not worry about that. So once we have all this given, then throws IO exception. If at all any errors, it will throw an IO exception. So otherwise then it comes to the next line here. See, what we have now is value dot to string. Okay, see, you observe here, what is the data type of the value? It is in the form of text. Okay, I told you long writable, text, int writable, they are all data types, built-in data types of Hadoop. Okay, now what we are doing is that value which is in the form of text, we are converting it to string. So this is a built-in method again which we are using, to string. So this TOSTRING, to string built-in method, will convert that value which is actually in the form of a text. Okay, it will be converted into string, and once it is converted, it will be stored in this yes. Okay, so again it will be taken one key value pair at a time, and it will be converted and it will be stored inside this yes. So if I had to just show you with this example, See, this was our value, which is in the form of a text. Its data type is text. It will be converted into string and it will be stored into yes. Similarly, the next from the next key value pair, the value will be taken, which is again having a data type of text, convert it into string and store it into yes. Similarly, the next key value pair and the next key value pair, it goes on like that. So now once that is converted and stored into this yes, what we do is now for string word yes dot split with a blank space. See, what is there in the yes? Now if I take the first key value pair, okay, so if I have to take the first key value pair, inside the yes we have this hello, how are you? Now what we do is we actually are doing the tokenization. We are tokenizing it. So you are going to split this entire thing, okay, based on the blank spaces. So we have one blank space here, we have one blank space here, we have one blank space here. So this entire string will be converted into 4 tokens. Hello is one token, how is another token, ARE is the third token, YOU is the fourth token. So like this tokenization is done. So for string word, so once we do that tokenization, it will be stored inside the word. Okay. So now if, see what happens now, first token is, that is first word is hello, okay, HELLO. Now what happens is we have this if condition, word dot length, if it is greater than 0. In the first word what we have is hello, right, first token. So its length is 5. So is 5 greater than 0? Yes. Since it's true, you will come inside the if condition and you are going to write the output. That is output dot collect new text word. So what is the data type of the word now? Word actually holds hello and its data type is text and it will be returned to the output file. So these are all temporary outputs, okay, not the final output. It's a temporary output, intermediate files it will be written. And then next is new int writable 1. So what is the data type of 1 that we are telling? It is of type int writable. So that is what you can see here. Hello is written and 1 is written. Now the data type of this hello is text and the data type of this 1, which is nothing but the value, is int writable. Okay, so that is why here we had given long writable text. This is input key value pair, data type of the input key value pair, and here we have text and int writable, that is the data type of the output key value pair. So now here what we are doing, that word HELLO, we take it and convert it into text and we write it. Then we take one and convert it into int writable and we tell that it is in the int writable data type and we are going to write it. So once we do this, similarly, this for loop keeps repeating. So how long this for loop keeps repeating? Until it has processed all the tokens. In the sense, first time it will be hello, second time how, third time ARE, fourth time YOU. So like that, it is going to take one by one each token of that first key value pair and it will be written. So once the first key value pair is completed, is done, it is going to take the next key value pair, take the value part, convert it into string. Okay, hi, I am fine. Okay, it will be converted, that will be converted again into string here. After converting it, again it will be split, and once it is split, each word at a time, whichever is the word length, whichever is greater than 0 will be taken, and that word will be written with one value associated to it. Okay, so that is how we are going to get this set, that is hello 1, how 1, r1, u1, hi 1. This set of key value pairs we are going to generate. Okay, so this is very simple. This is what is the mapper function actually uh, computation it is doing. Okay. Okay, so now once we know about the mapper function, now let's go to the reducer function. So what actually happens in the reducer function? Now I told you in the part 1 that after we get this as output from the mapper phase, then automatically the shuffling and the sorting will be happen, and the key value pairs will be given as an input to the reducer in this particular format, right? Key is nothing but that words, and value is nothing but that list, which contains how many times that is being repeated. Say for example, ARE repeated 2 times. So the value here is the list, that is 1 comma 1. Now you take another example of YOU. How many times it has repeated? 3 times. So in this list we have 1 comma 1 comma 1. So like this, we are going to give the input to the reducer. Okay. So now let's see the code of the reducer. Right. Now we have this reducer. So public class word reducer. It extends the MapReduce base and it implements the reducer class. Then see, this is again very important here. Whatever we give these arguments, text comma int writable. So now understand, this is again the data type of the input key value pairs, and these two, that is text comma int writable, are the data type of the output key value pair. So in this example, if I have to tell again, see here, the data type of the key here is text, then the value, the data type of the value, this particular list, what we have here, 1 comma 1 1 1 1. Okay, so this is nothing but in the form of int writable. Okay, now similarly here also, when it comes the output key value pair, their data type, it is again text comma int writable. Okay, so that is why here we are having text int writable, which is nothing but the data type of the input key value pair, and the next two arguments that we have, that is text comma int writable, are the data type of the output key value pairs, right? So then once we are inside this public void reduce, then text key. So what we are telling, there is one variable key and its data type is text. Then we have this iterator int writable. See, that is nothing but the values. So I told you right here, values. So what are values here? This 1 1 comma 1 1 1 1 1 comma 1, right? So that is what all values that we have. So now why we are using this iterator is, it has to iterate, or it has to go through with all the values which are there in this particular list. So we have how many ones here? 2 ones. So it has to take one by one and it has to add it up. Similarly, here we have 3 ones. It has to take one by one. It has to add it up. That is why we are using the iterator. Okay. So values, which is nothing but int writable, we have to iterate through that values. Then again, output collector. The data type is text comma int writable. Text comma int writable. And again, reporter R. And if any errors, it will throw exception. Otherwise, we have this. Now this is an important logic that we have to write here. We have one variable by name int count is equal to 0. Okay, now what we have is while loop, while values dot has next. Okay, see values. So what we are doing now, we are taking the values as long as we have values. Okay, that is let me just show you here in this scenario. For let's take this ARE. So as long, first we will take this one, then if there is one more one, we have to take that. Then similarly, like here also, as long as we have this one, the while loop keeps repeating. Okay, so now first time when you run this, values dot has next will return true. So while loop condition is true, enter inside. What you do is values dot next. So which is the next value that you are going to take it, store it in I. Okay, I data type is int writable. Then you just have to add it. Count is equal to count plus I dot get. Okay, so what we do now here is, we are taking this value 1. Okay, 1 we are taking from the first key value pair, we are taking this one and we are adding it to the count. So count is 0, 0 plus 1 will become 1. Again, that 1 will be stored in the count. Now after this, when you go back to the while condition, values dot has next. So what happens now? Is there any other value next here? No, there is only one value, that is, it's done. We have added it. No more is there in this first key value pair. So what happens? The condition of this while fails. It come out of that and it will write key. Okay, key key, which is that key am. Okay, that is one is that is the what is the key. Then am is written, am is written. Then count. What was the count? 1. So 1 in the form of an int writable data type, it will be returned to the output file. So once you are done with this, it will take up the next key value pair. Which is that next key value pair? ARE comma 1 comma 1. So now what happens? Now the key is ARE. Okay, the key is ARE and the value is 1 comma 1. Okay, so when it comes to here again, int count is equal to 0. Then we have values dot has next. So condition is true, enter inside, take that value, store it in I, and add it to the count. Okay, so count is equal to count plus I dot get. That is, count value is 0, 0 plus 1 is 1. Count value becomes 1. Now when you go back, this while condition again, values dot has next. Okay, is there a next value existing there? Yes, there is. Okay, so condition is true, enter inside, take that next value, add it to the count. Previously count was 1, so 1 plus 1, now it will become 2, store that 2 in the count. Now again go back, is there any next value? Now this time there is no more values, so what happens? This values dot has next, this will return a false, that is 0. Condition fails, come out of that. So once you're out, what is the key? Key is nothing but the ARE R, and what is the what is the value? Value what is the count? Count is nothing but 2. So what you will do, you to the output file, you are going to write R ARER comma 2. Okay, so that is what we have got here, ARE comma 2. So like this, next key value pair, next key value pair, next key value pair, like this one by one will be taken and it will be done. Okay, so now one important point you need to understand here is how this one by one key value pair is taken. So now you have to understand the Hadoop is a distributed file system, and this MapReduce jobs are distributed across different nodes, and data is also distributed. So each node will be taking some part of this data and it will be doing the operation. Okay, so that is what is the reduce function. Now we come to the word count.java, which I told you is like a main program or a driver program for that matter. Okay, so where we do all the required settings for the MapReduce job to run. Okay, so we have a public class word count which extends and extends configured. Okay, so we have to configure this. This particular MapReduce job needs to be configured before you give it to the Hadoop environment for execution. Okay, so it extends this configured and it implements the tool, and we have this run. So which for which we pass this string and args. Why this string and args is, see, when you run the program, you have to give actually the in path name, path of the input file and the output file. Okay, this is a command line argument. When you run the program, in that command line only, we have to give the input file name and the output file name. Okay, so if you miss out on giving the input file name, or if you miss giving the output file name, then arguments length will become less than 2. So then it will tell, please give input output directory correctly. Okay, so two arguments must and should has to be passed. One is the input and the another one is the output directory. Okay, so anything less than that, when I execute, you'll understand it. I'll again tell you that. So anything less than 2 arguments, if you give, args length will be less than 2 and you are going to get this exception thrown. Okay, otherwise if everything is correct, if you have clearly mentioned the input directory and you have clearly mentioned the output directory, then it comes to this line, So new job conf. So you are scheduling. See, this is a object that you are creating conf of type job conf, and so yeah, we are going to give this word count dot class. Okay, this is the word count dot class file that we are giving for this job conf function. And yeah, file input format and file output format. See, what we are doing here is set input paths, set output paths. Where is the input path, where is the output path? We have to set it. Now from where it will be taken is conf command new path args of 0. So this is, as I told you, command line argument. In args of 0, the input directory name or the path name of that input directory will be stored. In args of 1, output directory will be stored. So both of them, their length is 2. So if you don't give them both of them, this condition will fail. So you know args is the argument that we are going to give. So if args count is less than 2, error. Otherwise it's correct. So first, whatever is stored in args of 0 will be taken as an input directory path name, and args of 1 will be the output directory. Okay, so that is what we are setting here: file input format, file output format, set input path, and set the output path as args of 0 and args of 1, that is input directory and the output directory. Then next is we have to call the word mapper class and the word reducer class. So conf dot set mapper class, which is our mapper class, word mapper dot class. The reducer one is word reducer dot class. See here, these two, word mapper and the word reducer. Okay, so that is what we are setting next. Then okay, yeah, so this is one important point, that is a set map output key class. See, just break this, you'll clearly understand. It looks very lengthy, but if you see here, set map output key, what does that mean? The mapper function is there, right? It also gives the output in the form of key value pair. Okay, so mapper output key class, okay, which is nothing but text dot class, right? So quickly to show you here, see, map output. Okay, what is the output of the mapper? Key value pair. What is the data type of the key? Text. What is the data type of the value? Int writable. Okay, this data type, that is text, is actually implemented using the class. Okay, these data types are implemented using the class. So that is what we are telling, text dot class. So map output key class is text dot class. Then map output value class. Okay, map functions output value class is int writable dot class. Okay, so that is what we are doing here. Then next is set output key class. See here, it is set output key class means final output, that is nothing but the output of the reducer. So here you need not have to tell set reducer output key class, not required. Okay, when you tell set output key class, it is nothing but the final output, nothing but the output of the reducer. So you're telling output of the reducers uh, key. Okay, its data type is text dot class. So let me just show you here. So this is the reducer. Output of the reducer is in the form of key value pair. The data type of the key is text. The data type of the value is int writable. Okay, so now that is what you're telling. Set output key class is nothing but text dot class, and set output value, okay, value class is int writable dot class. So once you set all this, now the finally you have this job client dot run the job. So when this line gets executed, actually the jobs start executing. The MapReduce job starts execution. Okay, resources will be allocated for that, and the execution will start. Okay, so this is the main function. which is, as I told you, is a command line arguments. Okay, we have to give that string args. Okay, which includes in args of 0, you'll be storing the input directory, and in args of 1, you'll be storing the output directory. Okay, then tool runner dot run new word count dot args, and with some exit code. So on successful, they are all built-in exit codes. This tool runner dot run will return. So if successfully the jobs are completed, some with some exit codes, it will be returning, which will be stored in this exit code, and system.exit with that exit code. So sometimes there may be some problem, resource allocation problem, or there may be some failure of the nodes. In that case, they return some exit codes, return value. Depending on that, it will actually tell you whether the job Hadoop MapReduce job is successfully completed or not. Okay, so this is all about the word count program. So this is like a main program, main or a driver program. This is about the mapper and the reducer. Now, is it required to create these three different files and do it? No, absolutely not. It's your choice. If you want to put all the three into a single file and do it, yes, you can do it. It will be executed. If you want it to be in three different files, yes, you can do it in a three different files. Absolutely, it will work. Okay, so the main reason for making it in three different files is if at all any errors, it becomes easier. You'll understand in which particular file the class there is an error, and easily you will be able to debug that. That is the reason why we have separated it, and we have done it as a Java project kind of thing. Okay, so now, right. Okay, so once we are done with the explanation of this uh, code. Now we'll see how to execute or how to actually run this code. Okay, so we have this project word count. Whatever we have done, we have included the external Hadoop jar files into this project, and we have these three class files, that is word count Java, word mapper .java, and word reducer .java. Now let's go to the project word count, our project, and right click there. Now just click on this export. Then here you'll get some options like this, and just click on this Java, and you have to click on the jar file. Okay, then click next. Right, so now once you are here, you have to just uncheck this class path and this project. Okay, just uncheck those, and in this jar file here, you have to just give any name or that you want for your jar file that we are going to create. So I'll just go to browse, and let me just select the desktop only. I'm going to create the jar file on the desktop, and I'm going to give the name for that. Say for example, let me just give it as WC. Right, I'll just give it as a WC only. Then click on OK. Right, so once you click on it OK, just click on this finish. So the jar file is going to be created. Since I have already executed this program previously, the jar file with the same name already exists. So what you can do is you can just give it to overwrite it, not a problem. It will be overwritten. So now when you go back on your desktop, so you should be able to see that jar file. Yeah, here it is created wc.jar. So if you have any errors when you are typing this code, either in the word count or in the word mapper or even in the word reducer, you'll have to first debug that. Without that, the jar file will not be created, and only when there are no errors, successful compilation will be done and the jar file will be created. Okay, so now once the jar file is created, let's now just minimize this Eclipse. Let's go to the terminal. Okay, now open a terminal. Okay, our further execution all will start from here. Let me just increase this so that it will be clearly visible to you. Right, now we have to, what is the next step that we need to do is we have to create an input folder on the HDFS, not on our local file system. Okay, so how do we create a folder, input folder? Okay, on HDFS is we have to type this command You know, all of you know that mkdir is the command that is used for creating the directory, right? So now uh, it's on a local directory that will be created, but we want it to be on the Hadoop. So what we have to do is this mkdir, suffix it with another part of the command, HADOP, Hadoop fs, that is nothing but Hadoop file system hyphen mkdir, make dir, and give the directory name. Okay, so I can give the directory name as say input input. Okay, let me just give this, hoping that that directory doesn't exist. Let's see whether it is successfully created or not. If there is already a directory by that name, it will give you error. Okay, cannot create directory. Input file exists. Okay, input file exists. Let me just change it with in and IP, and let me check it. If already one more directory, yeah, no, file that IP name of the directory is IP. It's not existing, so now it is created. Now understand, it is not created on your local file system. If you are doing it on your Linux, your local file system is ext3. Okay, and for Hadoop, it is Hadoop distributed file system. So this directory is created on a HDFS platform. Okay, then we have to create a file with some text and copy it in the input folder. So what we'll do is some sample file we will create so that we can give it as an input. Okay, so I'll use gedit, then some s.txt file, open, and yeah, it's already there, some content in that. What I'll do is I'll remove all this content in s.txt. I'll take the same example. What was there in our file? Hello, how are you? Hi, I'm fine. Thank you. How are you? Okay, I'll copy this and let me paste it here. Fine. Save it. Then I'll close it. Okay. So now we have created that file. Now this particular file s.txt needs to be loaded into the IP. Into which directory? I have to load it into IP directory. Now this IP directory is actually in Hadoop distributed file system. Whereas this s.txt what I have created is in my local file system. Okay, so now I have to load it. So how do I load it? We have a command called as put command. So using this put command, we can uh, put the data from our local file system into the Hadoop distributed file system. So the command is again HADOP Hadoop fs, then minus put is, this is what is the command. Okay, then which file we want? Yes dot txt is the file, and this x dot txt, where should I put it? I should put it in the directory IP. Okay, so inside this IP, I will specify where it has to be copied. So let me just give the name as say ss dot. Let me just give it as yes dot txt. Okay, I can give anything, ss dot txt. Okay, let's hit the enter key. Yes, now what happened is this yes.txt which you created with some lines, that file which was created on the local file system, that is ext3, is now loaded into this particular directory IP. Okay, in this, where is this directory? This directory is in HDFS, and inside this directory ss.txt file is created, and whatever is the content of this yes.txt will be loaded into this ss.txt. Okay, so this is how we are going to load the input file. Now we have to run the jar file. Okay, so the command to run the jar file is again Hadoop. Next up is we are now going to run the jar file. Okay, Hadoop jar, and we have to give that jar file path name. Okay, so where is that jar file that we have created? We have created it on the desktop. So what I'll do is I'll just go here, right click on this, and properties, yeah, it should open. So here is the location, slash home slash training slash desktop. Okay, so this is one way of doing it, or else you can just go here, right click, and copy it, then come back to the terminal, right click, and again paste it. Okay, so you have the path name here, Hadoop space jar space home slash training slash desktop slash wc dot jar, right? It's now ready. Then we have that class, that is the main driver program, that is word count. Okay, then see, as I told you, now listen, we have to give as I told you, it's a command line argument. We have to give two parameters. Now one is the input directory and another one is the output directory. Okay, so if you just give only input directory, then that args length will be less than 2. Okay, so that is what I had already showed here, this one. Here, yeah. So this args length will be less than 2 if you give only one directory. So two directories we have to give, nothing but two folders, okay, path name. So one is the input directory, another one is the output directory. So now let's go here back again. What is our input directory? It is IP. Okay, so I'm going to give IP, and there is one file inside that. We need not have to mention that file, it will automatically take that file. Okay, then once we have that IP slash, then output file directory. Again, this output file directory should not be existing. It should not be already there on the Hadoop distributed file system. Same name if you give, again you will get a error. So try to give a different name. Avoid giving the names of the folder which already exist. So let me just take some name as OUT slash. Okay. Then let me just click this. So hopefully now the everything is fine. The MapReduce job will start. The execution will be started. Yeah, it's started. Okay, so now you can see here, map is also 0%, reduce is also 0% now. First mapping has to be done, then the reducer will start. Let's wait for some time. It will show you how much percentage of map is complete, how much percentage of reduce is complete. Since we are doing, our input file is very small, but still it is taking time because we are doing it on a virtual machine and it's a pseudo cluster, that is a single node cluster. Okay, it's not a multiple node clusters. In real time, when you do it on a multiple node cluster, it will be relatively very fast. But since we are doing it on a single machine, it takes some time. Okay, let's wait for the completion of the map job, then let the reduce job start. Okay, see here now, map 50% completed, reduce is still 0. Then once the map is completed 100%, the mapper function has done the job, then the reducer will start now. So reducer also completed 100%. So you can see here. Okay, so yeah, here. So mapper also completed 100%, then reducer started, reducer also completed 100%. So we have some other parameters here, job completed with that exit codes, number of counters 23, job counters, all this data you can just go through with this. File bytes written, how many file bytes, HDFS bytes read, how many bytes it has read, 267. And yeah, slots and data local map tasks are 2, and map output bytes, map input bytes. Okay, how many bytes given as an input to the map, all that you'll be able to see here. Okay, then is there anything important that I can, so it will show you how much time is spent for the map, for doing the map, how much time is spent for doing the reducer, all that you can see. Let's not much worry about that. Let's see the output now quickly. um, we have to see that output which is there in our output directory. Okay, so which is our output directory? What is the name I had given? It is yeah, OUT, right? This is what is our output directory. So you'll be able to see the output in that particular directory, whatever you have specified. So how do I see that? Again, HADOOP Hadoop space FS space minus ELS and yeah, out. So you know, minus ls is listing. Okay, so I'm trying to list out which are all the files inside this particular directory. So now you have 3 files here. log file and success file, and this part hyphen 00000. Actual output will be stored in this particular file. Okay, so how do I open it, and how do I see that? So what you can do is you can either use cat or gedit options, and you'll be able to see the content of that. Yeah. Okay, so now once we are done with the execution, now let's see the output. So what is the command that we have to type for that? Say hadoop fs, then minus cat, then the directory name out slash part hyphen 00000. Okay, so this is where we have to find our output. Yeah, we have got this. Hello once, hi once, how two times, thank one time, am one time, are is two times, fine is one time, I is one time, and finally YOU three times. Okay, so this is what is the word count analysis program using the MapReduce programming technique. Okay, yeah, that's the end. Thank you all for your patience listening.